Hello students. Hello and welcome to this video. In this video, we will solve question number 91 to 100 of determinants. The link to download the PDF will be in the description of the video. At the end, I will show you how you can download and maintain a updated copy of the PDFs, as well as I will show you my question answer website where you can come and ask questions. Because in YouTube, you can't type things like this, that is determinants, for example. So YouTube comments are not really suitable for mathematical problems. So without further ado, let's get started. Question 91 says that if 2s is equal to a plus b plus c, show that the determinant which we have is a square, s minus a whole square, s minus b whole square, s minus b whole square, s square, s minus b whole square, s minus c whole square, s minus c whole square, s square is equal to 2s cubed times s minus a times s minus b times s minus c. So what we do here is we let alpha is equal to s minus a. So remember that 2s is equal to a plus b plus c. Beta is equal to s minus b and gamma is equal to s minus c. Now we see that beta plus gamma is 2s minus b plus c is equal to a. Gamma plus alpha is b, alpha plus beta is c, alpha plus beta plus gamma is 3s minus a plus b plus c. That is 3s minus 2s is equal to s. So once we have that, we can write the determinant as beta plus gamma whole square, alpha square, beta square, gamma plus alpha whole square, beta square, gamma square, alpha plus beta whole square. And we have solved one such problem, and the determinant will be 2 alpha beta gamma, alpha plus beta plus gamma whole cube. Now, if you want to see this problem 91 like problem, I will show you where it is solved. So question number 48. Okay, or rather, yeah, 48. So if you see the solution of 48, right now you would say that this is not square, but if you see the problem of 48, you will see that how this is same problem. Okay. So if you have not watched my previous videos, you need to go and watch that. So once we have this, we can say that this is equal to 2 times s minus a times s minus b times s minus c s cubed. Question 92 says, show that x minus by minus cz, ay plus bx, cx plus az, ay plus bx, by minus cz minus x, bz plus cy, cx plus az, bz plus cy, cz minus x minus by is equal to x square plus y square plus z square times a square plus b square plus c square times ax plus by plus cz. So in this question, what we do is we say C1 is equal to AC1 plus BC2 plus CC3. And once we do that, what will happen is that our first column would have a square plus b square plus c square, and we take that out, and it will be a multiple. It will be I have another factor xyz which is here, and since we multiplied C1 with a, we divide with that. And once we have this, what we can do is we can say R1 is equal to X R1 plus Y R2 plus Z R3. So since we multiply R1 with X, we divide by X. And we will have X square plus Y square plus Z square here in the first row. So we take that out and we will have A square plus B square plus C square, X square plus Y square plus Z square upon X. Once we have that, we have this determinant here. So what we do here is we do R2 is equal to R2y minus R1 and R3 is equal to R3 minus ZR1. So we get our two zeros and then we evaluate the determinant, we get X plus by plus C. So it looks quite intimidating and it is slightly difficult problem. Question 93 says that find the value of theta between 0 and pi by 2 satisfying the equation The equation is the determinant 1 plus cos square theta sin square theta 4 sin theta cos square theta 1 plus sin square theta 4 sin theta cos square theta sin square theta 1 plus 4 sin theta is equal to 0. So what we do is we do column 1 is equal to column 1 plus column 2 plus column 3, and our first column becomes 2 plus 4 sin 4 theta, and the remaining two columns are unchanged. So we take 2 plus 4 sin theta out, and then we do R2 is equal to R2 minus R1, and R3 is equal to R3 minus R1. So we get plenty of zeros, and we can expand along the third row on this one. So what we will have is 2 plus 2 times 2 plus 4 sin 4 theta is equal to 0. That is sin 4 theta is equal to minus half. So 4 theta is equal to 7 pi upon 6 or 11 pi upon 6. So theta is 7 pi upon 24 or 11 pi over 24. Question 94 says that if a square plus b square plus c square is equal to 1, then prove that we have a complex determinant here. It is a square plus b square plus c square times cos phi, ab times 1 minus cos phi, ac times 1 minus cos phi, ab times 1 minus cos phi, b square plus c square plus a square cos phi, bc times 1 minus cos phi, ca times 1 minus cos phi, bc times 1 minus cos phi, and c square plus a square plus b square times cos phi is equal to cos square phi. That is what we have to prove. So what we do is we multiply first column with A. First row with A. Okay. Multiply first row with A, second row with A, and second row with B, and third row with C. And then we do R1 is equal to A R1 plus B R2 plus C R3. Okay. And then we have this particular determinant. Okay, I will not read it because it will take a lot of time. And once we have this, we do R1 is equal to R1 plus R2 plus R3, and we take out A square plus B square plus C square, which will be in the first row. And once we have this, we can do C1 is equal to C1 minus C2, and C2 is equal to C2 minus C3 to get two zeros. And once we have this, we can evaluate this to be a square plus b square plus c square times a square plus b square plus c square whole square cos square phi is equal to cos square phi, because a square plus b square plus c square is 1. Question 95 says that if none of the ABC is 0, so that minus BC, b square plus AC, c square plus AC, a square plus AC minus AC, c square plus AC, a square plus AB, b square plus AB minus AB is equal to AB plus BC plus CA whole cube. So what we do here is we divide on the outside by ABC, and then we multiply row 1 with A, row 2 with B, and row 3 is equal to with C. So see, this is again instead of underscore attack minus. So the operation is written here. Once we have this, we can take A from first, we can take A, let me see where we can take A from. We take A from first column, and B from second column, and C from third column. So this is A square plus AC. So, sorry, okay. Minus BC became ABC. B square plus AC became AB square plus ABC, and AC square plus ABC. Okay, so this would be A square B plus ABC. So there is typing mistake here. It is not A square B, it is A square B plus ABC. And then what we do is we take out A common from first column. Here, this is again there is a mistake here. This would be A square C plus ABC. Okay. So there is typing mistake again here in these two places. So now we take ABC common from first column, second column, and third column respectively. So we'll be left with minus BC, AB plus AC, AC plus AB, AB plus BC minus AC, BC plus AB, AC plus BC, BC plus AC, AB. Now once we have that, we do R1 is equal to R1 plus R2 plus RC. Our top row will become AB plus BC plus CA. So this has become 1. Once we have 3 ones, you know what to do. We do C2 is equal to C2 minus C1 and C3 is equal to C3 minus C1. We get 2 zeros here. And then we can expand along the first row with this one, and we'll get AB plus BC plus CA whole cube. Question 96 is that if u, v are functions of x and y is equal to u upon v, so that v cube d square x upon dy square, this is the second order differentiation of x with respect to y, and the determinant is equal to u v 0, u prime, d prime, v, u double prime, v double prime to v prime, where primes denote derivatives. So u prime is the first order derivative and u double prime is second order derivative. So we have this question. So we are given that y is equal to u upon v. So we compute vy upon dx. That becomes vu prime minus u prime upon v square. Okay, you need to know calculus for this. Alright, there is no escaping that. So v square dy upon dx is equal to vu prime minus uv prime. So v cube dy upon dx becomes v square u prime minus uv prime. Now we need to get the second order term here. So we differentiate again. We get v cube d square y upon dx square plus 3v square v prime dy upon dx is equal to 2v v prime u prime plus v square u double prime minus uv v double prime plus minus uv prime plus u prime v multiplied with v prime. So now we can substitute this v square dy upon dx from here, and we get v cube dy square upon dx square is equal to, this is not really a square, this should be d square y, second order differentiation of y with respect to x is equal to minus 2u prime vv prime plus 2uv square v prime square, it should be v prime square, plus v square u double prime minus uv v double prime, which will be equal to our delta. Question 97 says that if a is not equal to 0 and a is not equal to 1, show that x plus 1, x plus a, x plus a square is equal to a cube times 1 plus x times a cube minus 1 over a square times a minus 1. So we are given this determinant, and what we do is we split along the first column. So this 1 0 0 comes here, okay, and this remains here. So now what this we can expand quickly, okay, because we have 2 zeros. So the first determinant, what we do is R2 is equal to R2 minus R1 and R3 is equal to R3 minus R1. So we have got this determinant now, and we can expand along the first column. So upon expansion, it can be easily shown that it is indeed equal to right hand side. Question 98 says that if p plus q plus r is equal to 0, prove that PA, QB, RC, QC, RA, PB, RB, PC, QA is equal to PQR, ABC, CAB, BCA. So left hand side we expand, okay. So upon expansion, it is not ideal to expand it, but anyway, we have expanded it and we landed at PQR times A cube plus B cube plus C cube minus 3ABC. You can pause the video here and note down the calculation, and if there is any mistake, let me know. So once we have this right hand side, we have PQR, ABC, CAB, BCA. So you know what we can do is we can do column 1 is equal to column 1 plus column 2 plus column 3. which will give us AB plus B plus C, and we take this out, and then we do our R2 is equal to R1 minus R2, R2 is equal to R2 minus R3, we get two zeros, and then we expand again, we get the same as left hand side. Question 99 says that show without expanding that 1a square, 1b square, 1c square is equal to 1bc b plus c, 1ca c plus d, 1ab a plus b. So what we do here is we take the right hand side and we divide from outside by ABC, and we multiply first row with A, second row with B, and third row with C, as we have indicated here. So we get ABC, A times B plus C, B times ABC, B times C plus A, C ABC, C times A plus B. Once we have this, we take ABC out from the second column. So, and then we exchange C1 with C2. So once we do that, since we exchange one column, we put a negative sign. We have got 1, 1, 1, ABC, AB plus AC, BC plus BA, CA plus CD. So now we do column 3 is equal to column 3 minus AB plus BC plus CA times C1. So this becomes minus BC minus CA and minus AB. Now we take the minus sign out, we get 1 ABC, 1 BCA, 1 CAB. Now again we divide by ABC and we multiply first row by A, second by B, and third by C. Once we have that, we take out the ABC, we have got this, and then two column exchanges will give us the desired result. Question 100 says that show without expanding that the determinant x square plus x, x plus 1, x minus 2, 2x square plus 3x minus 1, 3x, 3x minus 3, x square plus 2x plus 3, 2x minus 1, 2x minus 1 is equal to small a times capital A plus capital B, where capital A and capital B are determinant of third order not involving x. So again, it's a difficult problem. So what we do is we split the first determinant, we keep x square to x square in one, and remaining x, 3x minus 1 to x plus 3 in another. So now we have these two determinants. So here what we do is we do R1 is equal to R1 plus R3, we get 2x square, 3x, 3x minus 3, 2x square, 3x, 3x minus 3, two equal rows. So this will be 0. Now the second determinant, what we do is column 1 is equal to column 1 minus column 3. Column 2 is equal to column 2 minus column 3. We get 2, 3x minus 2, 2, 3, 3x minus 3, 4, 0, 2x minus 1. And then we expand this second this determinant by splitting the third column. So we have x, 3x, 2x in 1, and then minus 2, minus 3, minus 1. So x we can take out from here, and a would be 2, 3, 1, 2, 3, 3, 4, 0, 2, and b would become 2, 3 minus 2, 2, 3 minus 3, 4, 0 minus 1. So this way we have two determinants of third order which are independent of x. And with this we come to the end of problem number 100 of determinants. Now I will show you my book. So you come to my website ashtabapur.org and you can download algebra, trigonometry, and coordinate geometry PDF from this second, third, and fourth link. And the downloaded PDF will not have the date, so you can copy this date and add it to your PDF, and after 15 or 30 days you can come and check again whether the PDF has been updated or not, and then you can download again and update the date again. This HTML format I will remove. The PDF quality I'm not very happy with the Dropbook, so I'm again completing this using text, so or typist. Now the question and answer website is, you can come to the 8th link and or go to kunjika.ashtabapur.org. You can come here and make a login. You can ask your questions by tagging with algebra, calculus, geometry, coordinate geometry, probability, trigonometry. So I can help you with these subjects up to class 12. And if your question doesn't match, you can tag it in a generic fashion with mathematics. So let's build a community and learn from each other by asking and answering questions. So with this, we come to the end of this video, and I will meet you tomorrow with 10 more problems on determinants. So thanks a lot for watching the video. I hope that you found it useful and were able to learn something. So we'll meet now tomorrow. Till then, stay curious, keep learning, and most importantly, enjoy.